So friends, you're welcome to part 3 of DNS tutorial. Here we will discuss about the caching, how caching works, what are caching only servers, what is round robin technique, zones delegation, split DNS, TTL, and finally we will discuss about paging and scavenging. So first of all, let's discuss about caching. As you're watching in the picture, there are two clients, client 1 and client 2, and this is suppose the local DNS server. So whenever client 1 makes a query to local DNS server, suppose the query is for server a.contoso.com. Now this local DNS will forward the query to its forwarder, or if forwarder is not configured, the query is forwarded to root hints, and then the another DNS, maybe the top level domain, and finally the query is forwarded to the authoritative name server for that record. And because this is authoritative name server, so definitely it will resolve the query, it will give response back to the local DNS, and local DNS will response back to the client 1. Now suppose if another client, for example client 2, makes the same kind of query to local DNS. Now if local DNS will ask or will follow the same process, then it will be very stupidity. So what it does actually, it store the response of that query to its cache memory, and then when another client within the network asks the same query, it gives response from the cache. But cache has some TTL, and after expiring that TTL time, the cache automatically clears. Fine. So another thing is that if client 1 again asks the query to this local DNS server, actually the client 1 will not forward that query to the local DNS, because it has already resolved the same query, so it has its cache also, and it will resolve by itself. So it means client computers and the DNS servers both have the cache memory, and both can store the responses of the query for some time. You're watching here, it has asked the local DNS, and then the query is responses back to the client 1, and if client 2 again asks the query, the response is back from the local DNS itself. Fine. Now let's discuss about how can we clear the cache. Actually sometimes we need to clear the cache if we have made some modifications to the DNS server. Then these modifications will not be implemented to the client side till the record is in the cache of the client computers or in the cache of the intermediate DNS servers. So for that we need to clear the cache. Let's discuss how can we clear the cache. The computer on which I'm working right now, suppose this is the client computer, client DNS. So what I have to do to clear the cache, I will open command prompt, I will type here ipconfig /flush DNS, and it has cleared the cache. Fine. If we have to clear the cache of servers, then we have multiple methods, like we have DNS CMD, we have PowerShell CMD lets, and we can even clear using the DNS console. So first of all, let's discuss how can we clear the cache using DNS CMD. So for that, I'm going to a server machine, I'm opening PowerShell from here, I'm clearing the screen. So I have DNS CMD, I will type here, and actually DNS CMD is automatically installed, we don't need to install it. So I will write here DNS CMD and then clear cache. So it has been cleared. So I'm using PowerShell CMD lag to clear the cache. And what is that? The command is clear DNS server cache. Enter. It is confirming, I'm pressing Y, enter. So these were the two methods. Another method is using DNS server console. So I'm going over there, and this is the name of the server, 2012 server 2. I'm right clicking here, and this is the clear cache. Fine. So it has been cleared. So these were the ways to clear the cache. Let's come to the next screen. Caching only server. Caching only server does not hold any kind of resource record. These are not authoritative for any name server resource record. We configure it just to store the cache memory so that the name resolution may be fast. How can we configure it? It's very easy. I mean, we need to install the role of your DNS server role to your machine, and we need to configure root hints only, and other than that we don't need to configure any other thing. So it is very easy. Let's come to the round robin technique. What is that? This is actually the DNS load balancing mechanism. If you heard about NLB, or if you are aware about that, so NLB is used to balance the load between the servers. Round robin also works in the same way, but at DNS level. How can we do that? I'm going to explain that in next practically, but one thing I would like to tell you that I'm not very much convinced about round robin technique because it has some drawbacks. Means I will prefer NLB in comparison to round robin because it has some drawbacks. What are these? I'm going to discuss that, but before that let's understand how round robin works. You're watching in the picture, there is a DNS server contoso.com. It has multiple resource record. I want to configure for that round robin over here. So what I need to do, I need to enable round robin, and I need to create multiple resource records having same FQDN. As you're watching, the FQDN is same, www.contoso.com. These are 3 resource record having same FQDN, but every time IP address is different. So what will happen after doing that? Whenever a client will ask the query to DNS server, it is asking query for contoso.com. Now the query will be resolved to any of the IP address from this pool. First time, suppose the query is being resolved to 0.11. Now because it receives the IP address 11, then it will forward the query to this server 0.11. Next time, if it is asking the query, or any other client is asking the query to DNS server, then query is suppose resolved to 120, then the response will be forwarded to 120. So like this, round robin will load the balance between the multiple servers. But as I was saying that there are some limitations of round robin. So what are those? The limitation is the cache memory, which is at client side and the server side also. So whenever this client asks the response of suppose contoso.com, and the response is back to the client, that is 0.11. So now this client will store 0.11 to its cache. So next time, whenever the client will ask the query, it will not ask actually, because it has 0.11. So the query is directly forwarded to 0.11. So every time the query will be forwarded to 0.11. This is the same problem if there are some intermediate DNS. They also have the query, cache memory. So this is the problem with round robin, that till the time the record is in their cache memory, then till that time the query is forwarded to a single web server, suppose. So rather than forwarding to different servers. So at this point of time, your round robin fails. How can we perform a round robin? We just need to do 2 steps over here. First, we need to enable round robin, and another we need to create multiple resource records. So how can we do that? Just I'm showing you practically. So this is a server machine. I'm starting DNS console over here, and what I need to do is I'm creating multiple resource records. So like here I'm creating host A record. I'm writing here any FQDN, for example 1.orange.com, and writing IP address 10.0.0.11. Fine. Again I'm creating another resource record, for example 2, and sorry, I'm making a mistake. I need to use the same FQDN, and this time IP address is 10.0.0.2. okay, so add host and done. So now I have created two host A records which has same FQDN but different IP address. So it will resolve the queries to different IP addresses which are being given over here. Another thing what I have to do is I have to make round robin enabled. So for that I will go to the server name, I will go to properties, then advanced, then I have to see over here whether round robin is enabled or not. If it is not enabled, I will enable it, and that's it what I have to do. It is already enabled, so that's fine. So this is the way to configure round robin. Let's come to the next slide. Zone delegation. Sometime we can distribute some part of DNS zone to another locations for the purpose of properly managing it. So that kind of thing is called zone delegation. So it divides the load to different servers, and our management is also very easy. So how can we do that? Again, I'm going to server machine, DNS manager, and this is orange.com. I'm right clicking here and going to new delegation. So what can I do? Suppose I want to delegate a subdomain of orange.com. For example, I want to delegate delhi.orange.com to any Delhi server. So I need to add that server. For example, I'm writing here 192.168.0.103. So whatever the IP address of that server is, I need to write over here, and I need to resolve it. If there is a connectivity with that DNS server, it will be resolved, and I will click OK. So that is the way to delegate any DNS zone to any particular server. Next part is split DNS. How can we do that, and what is that actually? What we want, that there may be some internal clients of our company, and there are some external clients also. We want that if the internal clients request for any FQDN, then the query should be forwarded to any other DNS server or any other particular server, and if any external clients ask the same query, the query should be forwarded to another DNS server. So this is also a way to forward or to load the balance, but more than balancing the load, it is for security purpose also. So we can say this is a kind of DMZs. If we have to create different DMZs, then we can split the DNS also. How it works, you are watching in the picture. There is an internal client, there is an external client. So if internal client's query to DNS server, then this query is resolved to suppose 10.0.0.56. Sorry, actually 10.0.0.56 is the internal IP address of this internal LAN card, and the query is resolved to 10.0.0.39. And if external clients do the same kind of query, then the query is resolved to 65.55.39.10. So query is same, DNS server is same, but according to the internal or external clients, the query is resolved to different IP address. So this kind of concept is called split DNS. What is TTL? TTL is the time period up to which the record is stored in cache memory. We can make changes to it, but the default value of TTL is 1 hour. You know, we can make the TTL very short, or we can make the TTL very long also, but even again there are some side effects of that. If you are making TTL very shorter, then there will be a heavy load on the DNS server, because the cache memory will expire very soon, the resource record will expire very soon, and every time the request will forwarded to the authoritative name server, so there will be a much more load on authoritative name server. But if TTL will be very long, then the problem is, if you are making any kind of changes to the DNS, then those changes will not be implemented to the clients. Either they need to clear the cache memory, or the TTL need to be expired. So that's why we keep the TTL up to a intermediate time period, that is, 1 hour. What is aging and scavenging? Actually, aging is the process to keep the track of a dynamically registered resource record. What does it mean by that? If we have enabled dynamic updates, then all those computers, all those servers which are connecting to the DNS server, their resource records are automatically stored in the, what's that for that, in the zone. So these resource records are automatically created. But suppose after a long time they are disabled, they are not in contact, so these tail resource record need to be deleted from there. So aging is the process of keeping the age of that dynamically registered resource record, means how long that resource record is stored in the DNS zone. And scavenging is the process of deleting that resource record which is not being used for a long time. Fine. So let's see how can we configure aging and scavenging. So for that, I need to go to server machine again. This is a zone. I'm going to properties of it, orange.com. It is general. You're watching here dynamic update. So this dynamic update is none. It means there is no automatic updation of those resource records of those servers which are contacting automatically. If we are I'm selecting here secure and non-secure. Now there will be the resource record will automatically added to this zone, and aging will be started. So if we need to configure scavenging, I need to go to aging, and you're watching here, if I select it, then it will delete the resource record after a particular time period, which will be configured over here. Okay, in this refresh interval, that the resource record will be deleted after this time. But remember, only those resource record will be deleted which will not be used for this time. Okay, the active resource record will not be deleted. Fine. So this was scavenging and aging and scavenging. I think it will be clear to you. If you have any suggestion, please write a comment after this video. And if you want to study in detail, then you must see part 4 and part 5 of DNS. Thank you.